All right, so our last lecture, then we'll be done. So hopefully today is going to be a quick lecture. Give you guys more time to get your test prepared. So this may be the most important week for you in class. In our class, you have a test on Thursday from noon to 1:50, 1 hour and 50 minutes. So pretty much it's a easy test. We'll go over that a little bit later. So you have your project due this week as well, your final implementation, so if you haven't scheduled time with the project manager, you should, so that you get your demo completed as soon as possible. Okay. Then basically you go. It's a simulated acceptance testing. You go over checklist of features, and you got your grade for the final implementation. Pretty much. If he has doubt, he will look at your code. Otherwise, that may be it. Okay. So it's pretty straightforward for the final deliverable. You go and basically demonstrate your code and submit your report. You should have a way for him to check out your code from GitHub or something like that.
I was pretty much going to ask that. Do we have to submit source code?
You don't submit source code. Just give give where to download your code from GitHub or some other repository. As I mentioned, your GitHub repository should be self-contained. Okay, so that does not require specialized packages to run your code. Okay, typical Java setup would be okay. Right. So certainly the main thing in your final report is actually give the instruction about how to download, where to download, how to download, and how to build your code. Okay, that's the main thing. Certainly, listing the set of features you have finished wouldn't hurt. But the main thing he's going to be looking for would be, if necessary, you can go back to your report and extract the instructions, and also repository to get to your code.
So you just put that in the project report?
Yes.
And you submit that?
Yes.
Okay.
Yes. Project report should go into your D2L. Yeah. So everything will be documented in D2L. So your homework, your project should be in the D2L. Your source code is not expected to be in D2L. Doesn't make sense to make source code in D2L. Doesn't do anything there. So just in your report, you should give a repository give a link to your repository. No, as I said, so the report is fairly straightforward. Just the list of features you have implemented, you claim you have implemented. Then basically, where is your repository? And the instruction to build and run the repository. To demonstrate all the features you listed. That's all. That's all we need for your final report.
So just doesn't have to be.
No, I don't want to. I don't need your feedback on the project. I know the project sucks for you guys, right? But you have to do it. So I don't want to hear your feedback on the project because that's something I expect you to do it. You need to be able to do all these steps. Yeah. So what basically what we're looking for is you are able to package your code into a whole thing that other people can run. You are able to give instruction on how people actually can use your code. That's the last requirement. We are testing you on that final report. That's all. Okay? The demo is really a simulated acceptance test. It's armed with a checklist. You go through your demo, then you go off all the items on the checklist. You got your score. Now that you already have your homework back to you and all the 3 documents you already got feedback on, you should know where you are. Okay, well, we'll talk about the test. Some were more after our discussion on Teams. Any other questions before we go on?
So
So we should be initiating contact with the project manager to set up a time?
I think you should have received a link.
D2L unit.
If you are using a different email through your D2L, you don't check, and that could be a concern.
I'm not used to getting
Oh,
emails through there, okay.
I set up my detail email forward to my.
All I ever get is confirmation I started something, so I.
Yeah. So,
Okay.
so you know, so actually we are relying on D2L more and more. So you better configure D2L with the email that you do check. Otherwise, so instructors are sending a lot of emails through D2L increasingly. So that should be where you check.
And forwarding emails out of D2L, if you don't set it up to happen automatically, is basically impossible.
Yeah.
Like it won't let you forward a single email out of D2L.
Really?
But yeah, if you set up auto forwarding, all future emails will just.
Yeah, so D2L, I mean, so it's going to stay. If you're going to be here for some years to come, D2L is going to stay. So, yeah. Years ago, I mean, maybe 10 years ago, we had a big switch from Blackboard to D2L, but D2L has been here since. It's going to stay. All right. So our last lecture, actually going to talk about something we didn't do in class, which is team. So we'll look at, so this is basically before you go on to other classes, and also your capstone, which is going to be the main focus of the capstone is actually team-based project. Okay, how to work with a team on a relatively realistic project, pretty large team. We'll talk about all these concepts as we go. So essentially, nowadays it's almost impossible for one single person to do a major product. Okay, it used to be it's maybe possible, but not anymore. So typically, what you have is you have a team. However, you can't really software development is not picking up trash. You have a highway, segment of highway. You have 5 people picking up trash. It's going to be 5 times faster than one guy picking up the trash. Okay? It doesn't work that way in software development. You add more people to a team, does not generate linear productivity. Typically, it's actually a waste of linear. Okay? The more people you put on team, actually the increments getting smaller and smaller. All right. So so essentially, if we look at team organization, if you don't organize your team well, there are many things that can go wrong, right? So you have miscommunication or missing specification, or under specification or error in specification. You can get into trouble in many places, right? So essentially coordination is a key. Basically make sure that you guys are working on the correct modules and also working against the correct interface, okay? So that's why there has been a strong focus in our class for you to write down documentation at least once before you move on to other classes. I mean, writing is something we don't do much actually in our study once we get out of high school. However, writing skills are equally important as your programming skills as you move along your career. So specification certainly different from the articles we have been written in high school and middle school, but it's also a useful document. So many things can go wrong if you don't have a good team organization and communication. So maybe the teammates actually are perfectly fine, but actually since you have a bad organization, it could tank, right? So that's the individual team member may be incredibly competent, but the whole team may be incompetent. Another thing that happened a lot in our work is actually adding more people makes the communication really difficult. Okay, you start with three people in a team. You basically have a bi-directional communication among them. While you add another guy, basically you're adding 3 more. Okay, so quickly, if you're just adding people and they don't follow any procedure or organization, then you basically everybody can talk to anybody else. Then you will get into the situation that you'll be overwhelmed by communication. Basically, the result is everybody just having meetings every day and no progress made. Okay. So essentially, adding. So this is a very famous study that I've done before. Right? Adding additional programmers, programming personnel to a team when the project is late, basically makes product even later. So essentially, you took a cycle of the productive people and basically you have to teach other people about basic concepts about the product and essentially render the product, render the process later. You are not really working on the productive stuff. So teams are definitely necessary. There are two extreme of team approach. One is democratic team and the chief programmer team. So this is this has been, you can see ever since we had programming teams. This problem came up day one because this is a human team, right? All these problems not didn't just happen out of blue. It's actually human problems that we see in other places, right? Democratic team or chief programmer team. So democratic team basically is so-called egoless programming. So essentially say everybody is equal. Everybody equal. So people are not attached to their code. So you contribute equally to the programming team. What's wrong with that assumption? What's wrong with that assumption? I mean, even when we just started with talking about the concept of democratic team, you already know something is wrong with this approach. What's wrong?
Not everyone has a say.
Absolutely not. Okay, so our class as a whole, if you look at our class, we have 16 students. So, well, you guys don't have the same level of programming skills. Okay. So that's just a fact. It's not say, oh, well, we didn't have a good class. The matter of fact is, in any class you go, there always will be a distribution of programming skills. Okay, that's just a given fact. So you can't just get programmer of the same level. It's almost impossible. And also, egoless programming is also really hard to achieve, right? Everybody has somewhat ego, and once they start working on a module, they got really attached to that module. All right. So essentially that's a problem. Once you own a module, you own a module. Ownership is good, right? Ownership is good because people are taking responsibilities, but ownership is also challenging when you have a team environment because, well, so I'm actually maybe defending my work for defending my work, not actually based on merit. Okay, you can't say my code is bad, right? Although it's bad, but you can't say it's bad, right? So essentially that affects the team dynamic. All right. So egoless programming is actually restructure a social environment, restructure programmer value, encourage team member to find the faults. The fault may be classified as normal accepted event. Team as whole will develop as a group identity. Module will belong to a team, and the group people will work together. Wow, this is utopia, right? Never happen in reality. What close to it actually is what we are running today in industry, the agile processes. Basically through stand-up meetings, pair programming, and also shared ownership of modules. Okay. Actually, we actually didn't. So democratic team basically. Democratic society, actually everybody will obey the rule, which is not true even in our society, right? So essentially, so this is the extreme team concept, which is never really used in industry. What we use is a modified version of this. Basically, we use processes to enable, basically instill as much democratic value as possible here. So essentially, say we have stand-up meetings, shared ownership of all the module, all the code, pair programming, and you actually switch module every time you run a different sprint. Essentially, you are on every module. Everybody else will be on that same module later on, right? This is actually the practice of them, sort of close to democratic team. So this is very hard to manage because you're really depending on people being not selfish. Okay, that's kind of hard to achieve. So you have to use basically a process. Can be very productive. Work best when the problem is very difficult. Function really well in research environment. Okay, so democratic team have to spring up spontaneously, basically self-organizing. This happens a lot in research environment. Basically, the other half of my job, doing research. In that case, a lot of teams are self-assembling. I mean, so you have different universities working together. People across the globe work together on different things. So to share a project or something. It's not quite pure democratic team, but close to it. That's where this approach has the best effectiveness. All right. So then we're close to actually our practice today in software industry to actually encourage people to innovate. We're more leaning towards democratic team by all the agile processes. Say extreme programming, on Scrum. This approach we use processes to encourage people to contribute as much as they can. Right? It's not like they all contribute equally. You always have junior team members, senior team members on the team. Actually, through pair programming and collective ownership, you actually encourage people to learn from each other and mentorship. All right. So then the other extreme is called the classical chief programmer approach, which is basically tackle this explosions in communication, right? If you have democratic team, anybody can talk to anybody else. Wow, you have a lot of communication channels which could be bad, right? Even your Slack, you could be in trouble too, right? So you got the other extreme, basically authoritarian regime, which is okay. You have one guy really in charge, which is the chief programmer. Okay, so this is another extreme. Another extreme. Once we talk about extreme, you know that in practice it doesn't work. Okay. So this guy in charge, everything falls on his plate. Okay. He decided what programmer 1, programmer 2, programmer 3 would do, and also he has a programming secretary, basically take care of the boring details of programming. And also you have a backup programmer, which basically the sole job of this guy is to back up the chief programmer. Okay? What's wrong with this scheme? What's wrong with this scheme? What's wrong? Everybody wants to be the chief programmer. Nobody wants to be the other guys, especially not the backup programmer. Right? You have no job to do until you got called out. Right? So, and also being these slave programmers wouldn't be fun either, right? Because you don't make any decisions. All decisions were made by that chief programmer. Okay, this is essentially Stone Age, right? How we structure our team. Well, clearly this would not be practical today, but actually people tried it before. So actually there are only 5 lines of communication, which is way simpler than this. That's why kind of in military, you still have this commanding hierarchy, sort of like this, because you want that control hierarchy, command and control hierarchy, but in practice, if you have this as your army like working like this, I mean there's really no way they can win a war. So essentially the concept is we took this idea from medical industry, right? So actually, if you have hopefully have not been to a surgery room, this is how it actually works. The chief surgeon directs the operation, assisted by other surgeons, nurses, and so forth. Okay. So basically, it's all specialized and hierarchical. Okay. Make the commanding control hierarchy really easy. Okay? Again, we didn't invent this scheme. This is basically take directly out of our operation. Okay, this works in medical community because you need the bug has to stop somewhere. With that operation being successful or not, somebody needs to take the blame or responsibility, right? It works, and also it's small scale, right? If you have two surgeons working on the same patient at the same time equally, in a democratic team, that will be trouble, right? So because all our operation, no matter how complex it is still relatively small. Relatively small. But our programming is not same like this. So that's why this approach does not scale. Chief programmer has been the superhuman being. So one thing is that such a superhuman being is really hard to find. Okay, you do have such a super programmers like the creator of Linux, right? All these major software packages when they started, they always had a couple of or one chief programmer, which did a lot of things. Then you have the backup programmer, which is in a pretty bad job, which is basically say you have nothing to do, but you have to follow, you have to read code,